starting off with trigonometric equations in sine and cosine. One of the tricky parts about sine and cosine, or all the trigonometric functions, is they're cyclic, meaning when we put them in equation form, there could be and probably will be more than one answer. So sometimes we restrict the answers that we want to get. We'll start off with a couple of problems where we're not doing that. Sine x equals 0. Now we remember that this is true if x equals 0 degrees or radians, but it's also true if x is equal to pi, right? And it's also true if x is equal to negative 2 pi or 2 pi, and we can just keep going on forever and ever, because looking at our unit circle, our sine value, which is our y value on the unit circle, is going to be 0 at any multiple of our even multiple of pi, 0, 2 pi, etc., or at any odd multiple of pi, say 3 pi or negative 9 pi. So we need a way to represent this, and the way we've come up with is to say that it is any multiple of pi. At any multiple of pi, this will be 0. Sine of that value will be 0. One way to say that is x equals n pi. And that will, n can be any integer. So if n is even, we're talking about one of the values on the right side. If n is odd, we're talking about one of the values on the left side that's coterminal with pi. This would be our solution to this equation, sine x equals 0. Essentially, we have to find a way to identify every possible angle for which sine of that angle would be 0. Let's look at cosine x equals square root of 2 over 2. Now we remember the square root of 2 over 2, that's our 45 degrees, or pi over 4 is our reference angle. So that's going to be here, pi over 4. And cosine is also positive in the fourth quadrant. So that would be negative pi over 4, or maybe we could say 7 pi over 4. We could look at it either way. Now, we also know that if we add 2 pi, we'll land at that same cosine value, square root of 2 over 2. So again, we're going to need a way of representing this. We could say it's pi over 4 plus some multiple of 2 pi. So a lot of the times we'll do 2 pi times n, or sometimes you might see it written 2n pi. They're both accurate. It just means some integer multiple of 2 pi. It could be a positive, it could be a negative, just looking at going around full circles. Again, there's an infinite number of solutions to this set. We could call it 7 pi over 4 plus 2 pi n. And sometimes mathematicians like to see how efficient we could get. Since 7 pi over 4 is coterminal with negative pi over 4, you could write both of these in the same form by saying x equals plus or negative, positive or negative, pi over 4 plus 2 pi n. And that would get all of your solutions. Let's look at another one. One of the tricks we've got to remember in trigonometry is that we're not going to throw away all the algebra we've learned. We're still going to hold on to that. So when we get something that looks like 4 cosine x plus 3 equals 3, think back in your algebra days when you'd do something like 4y plus 3 equals 3. This is just a linear equation. And so what we'll do is solve it. Well, you know the steps. We'll get y equals something. And then we'll have something similar to what we did up here, where we have y equals 0, or sine x equals 0, or in this case, we'll have cosine x equals something. and that will give us our solutions. Now there is an addition to this problem. We've restricted our answers. We only want them to come in the first unit circle, so we'll be looking for values of x that are between 0 and 2 pi. We'll include 0, we won't include 2 pi. And that way there'll only be one circle's worth of answers. So to do this, we will start off with, let's see, subtracting 3 from both sides. So that gives us 4 cosine x equals 0. And then we'll divide both sides by 4, giving us cosine x is still equal to 0. And now we can look at our unit circle. And cosine x on the unit circle, cosine is the x value of the unit circle, so that's going to be when x is 0. And that's going to be up here at pi over 2 and down here at 3 pi over 2. So x is equal to pi over 2 or 3 pi over 2. And again, because we said we're only going to look at one circle's worth of answers, we're not going to have all of the plus 2n pi's. We don't have to worry about those. Alright, one more. Let's look at 2 sine theta plus the square root of 3 equals 0. We'll subtract, again this is a linear equation, what we've seen as a linear equation in the past. So we'll just subtract the square root of 3 from both sides. That gives us 2 sine theta equals negative square root of 3. Divide both sides by 2. That gives us sine theta equals negative square root of 3 over 2. So now we need to think about our unit circle. Sine is our y values. We want to know when our y value is negative square root of 3 over 2. And that would be down here and down here. So that would be at negative pi over 3, but we want to be between 0 and 2 pi, so we need to look at it coming from this direction. So that would be 4 pi over 3 and 5 pi over 3. So theta equals 4 pi over 3 and 5 pi over 3. Now just a note real quick, if you were to plug in to your calculator inverse sine of negative square root of 3 over 2, your calculator is going to tell you, well, depending on your calculator, it may give you a real ugly number, or it might say negative pi over 3. But negative pi over 3 is not within the restrictions they gave us. So it tells us about this angle right here, or a coterminal angle to that one, but it doesn't give us the 4 pi over 3 at all, and the 5 pi over 3, or the negative pi over 3, is coterminal with the answer we want. It's not the actual answer we want. So while you may need to use your calculator at times, be careful because it will lie to you. It won't give you the answer they're looking for.